So today we will be talking about enabling science and discovery at Georgia Tech with MVAPICH2. So let's welcome Mehmet.
Thank you, DK, for the introduction. Yeah, I'm a research scientist for Georgia Tech, and I work for the central HPC facility. It's not a center yet, but I'm going to talk a little bit about that. But most of you would know Georgia Tech. It's a good school, consistently top 10, very good engineering programs, a lot of smart students and researchers. And there are 6 colleges, and most of the departments in these colleges, not all, but I think we are close to all of them, they require HPC or some kind of computational research to stay relevant. And to meet this demand, PACE started, I think, back in 2009. It's a partnership between the researchers and Georgia Tech. And the idea is to, instead of using grad students, declaring them the new HPC person in the group and make them graduate 1 or 2 years later just because they have to figure out the HPC. We just wanted to take this conflict out of their life and started providing this HPC services. Currently we are 11 people in the team, and we have student assistants. And the support comes with some infrastructure. Of course, Georgia Tech invested on all of these blue boxes, blue-colored boxes here. There's infrastructure, space tooling, and there's a Georgia Tech cluster for any Georgia Tech researcher who doesn't have access to the clusters. They can just start running. So if you're a Georgia Tech researcher, if you have research fundings for HPC resources, they can purchase the resources and we take care of the rest. That's pretty much what this big picture tells. And this is how we were growing since 2009. Blue is the number of cores, and this purple line is the number of users. We are nearing 2,000 users now, and we have currently more than 200 cluster owners, PIs, or contributors. Close to 40,000 cores. They are all connected via one giant QDR switch, very flat. There are some leaves here and there, but it's pretty much the entire thing. Some storage, not impressive, but good enough. And we are connected to the internet too with 100 gigabits per second. So for the exchange researchers, for example, they can easily transfer data. And I think this green line here is put here as a joke. That's the growth of the PACE team members. I think it was around 7 here and it's like 11 here. So we have the scale. Anyway, so our first encounter with MVAPICH was in 2010. We were using MVAPICH2 before that, and we started with 1.4.1 version. And back then we didn't have a good organized structured PACE repository. We were installing things on demand. By the way, I was saying we were, but I don't work with them, but this is history. And in 2011, we started this PACE repository, and starting with 1.6, we used up to 2.0 until we decommissioned in 2015, very recently, in actually April this year. And along the way, this was our first encounter with MVAPICH2. Our first encounter with the MVAPICH2 team was because of a problem that we had. We received this shiny little, shiny new AMD nodes, 64 cores in each of them. It was very exciting, lots of cores in a single node. But we couldn't run anything more than 64 cores with MVAPICH2. And I wrote an email to the user group, and almost immediately I got an answer. And Dr. Panda himself was also included in the communications. There was a problem with the registration cache. And the impressive thing is that we had a workaround the next day, and eventually there was a fix. And we could just continue with the computations. And it was great to have that support and enthusiasm from the team. We, of course, had a lot of problems, but another crisis came in 2013. MVAPICH was hanging for a user, but that user was a very, very important person. Brings a lot of funding. And we had to solve that problem. And whatever we did, it was just hanging or sometimes crashing. We again engaged the MVAPICH2 team. They were great, and we found workaround in just 3 days. And the patch was released in 2 weeks. We were able to patch our instance and sort of stack, and the patch eventually made it to 1.9, I guess. So it was impressive for us to receive such a level of support and help from the team, and we really, really appreciated that. Now we are working in our new baby paid software repository, which we deployed recently. And we are recompiling almost everything from scratch, and we're going to be supporting starting from 1.9, and 2.1 is now the default. So this is how we see MVAPICH2. The great thing about MVAPICH2 is that it doesn't change the world on you just to provide you with some performance, right? We are using the same world, the same physics rules apply, so standard operating system, just regular OFED, and you have the regular compilers. The animal is also the same. It's the same code, MPI code that you wrote, and you have been maintaining for the last 20 years. Maybe Fortran, started with Fortran. And it works really well on the existing infrastructure. Ivy is an expensive investment. You want to get most out of it. You don't want to just have a highway, build a highway, and just start walking on it. You want fast vehicles, right? And MVAPICH provides us with that, with using just familiar technology. These wheels are like MPICH standard technology. But what MVAPICH provides is this extra boost, which makes all the difference. So it's really a breeze to work with MVAPICH2. And it's fantastic for system admin purposes too. Very low maintenance. And we use it for other purposes, like we have an acceptance testing. Every new machine that we receive has to go through this acceptance testing runs, and they need to run these for 10 days uninterrupted. If there's a problem with the hardware, they have to start from scratch. And it's pretty rigorous testing. We have a VASPO, for example. We call it the node killer case. With MVAPICH2, it crashed on a node, and it was a hardware issue. A technician came from the company and just did some soldering work on the motherboard, and we could continue. So we decided to keep that industry. LAMS, HPL, and we're also adding SPEC 2007 benchmarks in the mix soon. And we have, as I said before, we are recompiling the entire repository almost from scratch. And it's a breeze to compile things with MVAPICH2. We have high compilation success. We don't have a lot of trouble there. And another problem we have is the keep an eye on the network. Is it healthy? Is it performing as intended? Is it to the specs? And the OS2 benchmarks, especially the point-to-point benchmarks, are very useful to figure this out. We also wrote a small wrapper around it and reports slow links, because there's almost no way to get this information from subnet manager or the nodes. There are no errors reported, no slow links reported, but you get bad performance because of some cable issue. And the only way for us to figure it out is this, these OS2 benchmarks. And it's great to have this compatibility with debuggers and profilers. When a user has a problem with a code, you want to debug or profile the code using the same API stack. Otherwise, those are two different worlds, right? And so far, in our experience, MVAPICH worked great with Valgrind, Tau, and also adding a DDT and map profiler and debuggers. So here's our new repository. We are pushing 1 terabyte. We have around 50 MPI packages, and 54 of them are compiled with MVAPICH2, and 49 are compiled with OpenMPI. Of course, most of them are the same packages. They overlap. So we don't have a mechanism to keep track of the usage of MPI. We don't have XALT, for example, but what we have is a file that stores every time the user logged in. If the user wants those modules to be loaded when he or she is logged in, then they can list these modules like module RC, but it's different. And I just had a look at it and counted the preferences, and apparently a quarter of the users decides to load one API on their login, and 500 of them are preferring MVAPICH2 currently. 72 OpenMPI users, they are mostly using a cluster that doesn't have InfiniBand, so they are stuck with OpenMPI anyways. So this shows us clearly that the users are preferring MVAPICH2. And this is not because we don't give them the option. We provide a lot of options, combinations in the cluster. For any software, we have latest 3 OpenMPI and MVAPICH2 compilations. Each of them compiled with the latest 3 versions of GCC, Intel, and PGI. Some of them doesn't work, of course, but this is slightly growing exponentially 3. So they have the options. So users like MVAPICH2, and we do too, because we have good reasons for that, is getting every day. And I actually met Jerome last year in the Exceed conference, and he was presenting a poster. I went there, and it looked too good to be true to me. He was talking about this CMA-enabled MVAPICH and how it improves the intra-node performance. The first thing, of course, I went back and compiled the new version 2.0 GA. I think it's renamed as RC2 because I couldn't find that in the change logs anymore. But the only difference between RC1 and RC2 is that RC1 supports CMA, but it wasn't enabled by default. But with RC2, it was enabled, and you don't have to do anything extra with runtime or compilation time. And on a 64-core AMD nodes, we saw this picture. Blue bars are the old version, red is the new version. You can see how much reduction in the latency it provides. Just one incremental subversion upgrade with no effort at all. Same thing for bandwidth. Sometimes it's more than double improvements in intra-node communication. And this is important because this 40-core AMD nodes, yeah, they have a lot of cores in them, but it comes to the trade-off. They have 8 different separate NUMA sections. I was expecting 4, but hardware locality library says 8. And cache coherency is a problem. They have very limited memory bandwidth. So anything that will provide some intra-node communication improvements will be well, applied in these nodes. And it was for intranode, a single node. How about the overall performance for distributed applications? Leslie 3D is a SPECS 2007 benchmark. And what we saw with Leslie on another Intel cluster is between 1.9 and 2.1, there are consistent 10% performance improvements. This is really great, and you don't do anything, just go with the newer version, and you see these kind of improvements. And this is $1 million cluster, and 10% costs a lot of money. If you want to convert MVAPICH benefit to dollars, it is a good place to start. Now you will tell me that this is just a benchmark. How about real applications? Well, turns out Leslie 3D comes from this combustion simulator developed by Dr. Mehmet laboratory at Georgia Tech. It's a three-dimensional simulation which looks at the flows and combustions, and it can model very complex physics like swirl spray and also high-pressure rocket combustion. And this is a very demanding application. And with MVAPICH2, this group was able to come up with a linear. And if the problem size is small, they can even achieve superlinear speed up with these simulations. So, and Leslie, the benchmark that was included in SPEC 2007, comes from this code. So this is scalable code. They decided to include that as a benchmark. Another really cool project is by Dr. Wise. He is one of the leading developers of the ENSO project, which is the open source galaxy simulator. They can simulate galaxies and also look at the existing galaxies and interpret how they came up to be, how they were formed. And this may look like a photo from the Hubble telescope, but it's not. It's actually a visualization of one of the simulations they performed. They didn't run the simulation on Georgia Tech resources because it's a large one. I think they used Gordon. I don't think they used Trestles for this, but it was in San Diego. But John is a long-time MVAPICH2 user, but he has currently problems with some affinity issues, and he came up. He just demonstrated the issue, and we are currently working with the MVAPICH team to solve these. By the way, don't print out this slide. It will kill your toner. Another very interesting research is by Kostas Konstantinidis. They are developing bioinformatics algorithms to look at the how gut microbes are contributing to diseases or a healthy state. So, in the background, they are using MPI Blast and MVAPICH2, and they made their research available to the public by using this interface. They have a web server. If you visit this website, you'll see a set of tools. And if you select the tool called non-parallel, it's not non-parallel, it's non-parallel, it's highly parallel. And you can actually input your data and get the results. In the background, it's running the computations on a cluster and providing you with the results. And we were talking about this, and he mentioned that he is willing to put this tool to cloud. We also manage OpenStack. It was experimental, but we are very close to production. He asked us if he can use OpenStack, and my answer to him was, yeah, but maybe you won't be able to use MVAPICH2 because I didn't know that you were already working on virtualization support. So it was a very good thing to learn here. Another interesting research is Glenn Sijan. He is now chief scientist for the Air Force Technical Applications Center. He was the former director of the Radiological Science and Engineering Laboratory at Georgia Tech. And this is a radiation transport code, highly parallel. And there are some other codes which can do the same thing, but no other code can scale as well as this Pentron code. It's highly classified, but they gave permission to use the results here. And this shows the propagation of a flux from high energy state to low energy state. And I worked closely with them for these simulations, and they use those 64 AMD nodes. And without MVAPICH2 and very complex affinity settings, we had to create all of the options to find a good combination. But eventually, when it started working, they got the most benefit from those machines and came up with these. By the way, this is the OpenMPI hybrid code, which is also very interesting. So they're still working on developing this. So, and today, where we stand? Well, I came here to learn more about MPI. I'm not an MPI expert or an MVAPICH expert. But I was thinking that MPI, especially after reading Berkeley's roadmap to exceed, I said, MPI, OpenMP, these are programs used by old guys like I am. And in the future, there will be more exotic programming languages. But I stand corrected here. Because as long as there are messages to be passed, I think MPI will be there and MVAPICH2 will be there to provide this in the best way possible. And of course, MVAPICH2 is highly dependent on IB, but I think that without IB, MVAPICH2 can, if in the future it doesn't exist, MVAPICH2 can just keep up with the new technology and continue to be one of the top MPI providers. So I was thinking I wouldn't be able to use it for cloud services, but now I'm really excited. I'll just putting a ConnectX card on a hypervisor is not a problem at all, and I'll looking forward to try MVAPICH2 virtualization support. So there are a couple of known issues. The affinity issue that I mentioned before, and also we have a problem with MPI for Pi compatibility. We cannot currently provide MPI using MVAPICH2. We have to stick to OpenMPI, but this can be resolved, I guess. I don't want to offend anyone because there must be good reasons for these, but it would be great to have the ability to run MVAPICH2 on non-IB nodes. It can even, revert to MVAPICH2 and transparent to do this. And I agree, Mark mentioned that it's a pain to compile things. And if you need to maintain an MPI stack just for the Ethernet networks, it increases the complexity a lot. It would be great to have one compilation that would work everywhere. Maybe slower, but still it should work. And also, I was about to say this, suggest a framework to analyze and publish OS2 benchmark results. guess what? I learned about INAM, and I'm really looking forward to the demo this afternoon. So we can just scratch that off the list. And another thing we really need is official download links to the clean sources for old versions. Because sometimes users claim that old MVAPICH2 was faster, and we have to show them that it wasn't, and for that we need a clean source. So that's pretty much it. If you have any questions, please ask.
So let's thank. Any questions? Questions for me?
Hi. So I was just looking at the framework to analyze publish OS2 benchmark results. So like, what type of need do you see there?
Well, INAM will provide most of it.
It's basically just visualizing what's going on in it.
The problem is this: one of the clusters had a problem, and it was passing all of the whole health checks. Everything looked good from the outside, but they were claiming that's extremely slow. And we checked the cluster, we couldn't find any problems. Then we started running this point-to-point benchmarking latency test. We couldn't find the problem very easily because later we find out that the problem was bidirectional, not unidirectional. And we were doing just one-to-all tests and fast passing. We ended up running 4,000 tests and almost crashing the scheduler because there are 200 nodes. You have to try them in both ways. And only then we were able to find it. And then we are told, so if apparently you can find these problems, why don't you have a monitoring system that will check for these problems? And my answer was, sorry, this is very difficult to find. The subnet manager doesn't provide us that info, and it just dodges most of the experiment runs that we throw at it. So it's very difficult to keep an eye on it. So having some framework that will continuously keep an eye on the network and report slow links would be just tremendous with no effort. Because if I can talk, our only option is to submit these jobs which are highly demanding to cluster in idle cores and continue to run these jobs. But INAM will just solve that problem.
So, yeah, it sounds like a good fit.
Yeah, we are looking forward to try that.
Any other questions? Okay, just to add a few comments. So I think, I don't know, in MVAPICH2 you can also build for non-IB. It is there. It is the same as the MPH code. Okay. From the stack, there is a way you can build. It will fall back to non-IB.
I'll look into that.
Yeah,
I didn't know that.
No, it is there in the user guide. I mean, either you do it for IB or you do it for even TCP/IP.
Is it either or can I use the same stack for both?
No, it is the same code base, but you have to build now two different versions.
Yeah.
Okay. We will talk with you. Maybe Jonathan can or anybody can talk. And affinity problem, we are already taking a look at it. MPI for Pi also, we had a discussion. I think it is on our list. Now, coming to that last one, I think let me just clarify for everybody what is going on here. In the early days, we were keeping all the old versions. Then what happened, just like you showed some good numbers saying the next release is better, there are good people, there are also bad people. And those people, what they are doing is they are using the older version to compare their numbers and publishing it. And when it comes for review, I mean, we get a lot of these papers for review, and then they don't indicate any MVAPICH2 version. But if you take a look at those numbers, it is the older version. They are comparing like 5 years old version, and they might have done some tweaking, and then claiming that their design is better. So based on that, we took an active decision to discourage these people. Okay, so that's why you don't see this. But again, the field is moving so fast. A lot of people are telling these days, like there are all machines. People are trying to do automatic build. People have already a lot of applications with builds. They just don't want to change it overnight. So in fact, we have taken an active decision 2 weeks back. We'll have all those older versions available. So in fact, yesterday there was a note on the Discuss. If some of you have been monitoring, we posted a reply. So you will see them. They will be available, but may not be public. We need to see.
Yeah, they're not critical, but sometimes you need them, and you need a clean source, like untouched.
Yeah, so just the older versions, whatever has been released, they will be available. Okay. So we have done this, but I'm just telling the background of what is happening. I mean, in the world, you see all kinds of people, all kinds of issues we see. In fact, many times I think I have mentioned this also in the publicly earlier. I mean, every time a major deadline comes, SC, IPDPS, and all these things, you will see questions on Discuss will increase. Okay, these are the people who are trying to find out what is happening in the code. So they're writing something in a competitive paper, and as a user they say, yeah, what is happening on that module and all. So you can see that these are not installation issues. These are not the details. They want to write a paragraph, or they want to compare their design against this. I mean, the code is out there. Instead of going over the code, they want a summary of how this code has been designed. Okay, so obviously that is not the right way to proceed, because publications have been there. They should go and refer to the publications rather than asking these kind of things. So we have seen over the last 15 years all kinds of good, bad, ugly about an open source project. So we are trying to handle it in the best possible manner. So if you need any older version or something, just let us know.
Sure.
And we'll be happy to work with you. So I thought I'll just add that comment here for everybody's information. Okay. So any other questions? Okay, so if not, let's thank Mehmet. So we'll move to the next talk. It will be given by Antonio Gomez Iglesias from TAC.